So, okay, we have talked about the consequences. We have pros, of course, and also cons that we need to think about when we use this pattern. Can't see anything. That is not so funny because I have not shared. There we go. So, okay, let's take a look at the structure. The structure is actually not that that complicated. You have the model, package, you have the view, package, and you have the controller. So, okay, what dependencies are allowed? Anyone? Yeah? You go?
Controller view.
Yeah, the view can depend on the controller. This is fine. Anything else? Yeah?
Modden kan väl dependa på kontrollen också.
Can the mod depend on the controller? Yay or nay? Nay.
Ja,
If we look at it, this side of this is the user interface. And model cannot depend on anything in the user interface. So we don't want that. If you find that in our code, we have done something wrong. Yeah?
The other way around.
The other way around, exactly. Controller can depend on maybe this is what you meant.
möjligtvis.
Yeah. So we can have classes inside the controller that use classes that are in the model. For example, calling different functions on them, getting them back as a result. Yeah.
Can the view kan den hämta saker från model?
Absolutely. The view can depend on the model. This is quite common because often you get something returned from the model, it passes through the controller and you give it to the view. So the view knows how to visualize customers, for example. It can take a list of customers and visualize it in some way. So it probably calls different functions on these model objects, get name, get customer ID, or whatnot. So we use things in the model from types in the view. Yes?
Om jag kastar ett fel i model och då har skrivit koden så att felet fångas i kontrollen, blir det dependency då? Alltså från model till kontrollen.
So the question is, if you throw an exception from something in the model and you catch this exception in the controller, is the model then dependent on the controller? No.
Okay.
it can of course depend a little bit about the exception you throw. If you define this exception in the controller, you have you just make a subclass of the exception class, and you have this class in your controller, and then you make new controller exception blah blah blah. Then you have a dependency. But if you move this exception class into the model, where it probably should be, then you don't have a dependency, because it's only the controller that uses this exception, catches it. So that should be fine if you don't mess it up. Yeah, and yeah, we have this also. This dependency. This is often quite common that the controller uses the view. And we have a comment here in the chat. The view shouldn't depend on the controller. And, well, that depends on what flavor of module controller you would like to use. If you don't allow this, you decide to, well, we don't want this. Then you have a flavor called the supervising controller, because the controller is in charge of things. It supervises the view and the model. Okay, I'm doing these steps. I'm taking something from the view, looking at it. Oh, the user wants to log in. Okay, I need to collect the login name and the password, and I need to take these, and I need to shuffle it to the model, and I get a result, and I tell the view to do something. So the controller is kind of like the director of things. It's supervising. But in the pattern itself, it is perfectly okay to have that relationship. So you need to decide if you want it or not. And also depending a little bit on technology. If you use a framework like Windows Presentation Foundation, for example, it can provide easier code if you allow the view to access controllers. So you need to think a little bit about these options you have, and what you should do in your project, and you need to communicate these with the programmers, because if you just say model view controller, you are going to think about one thing, you are going to think about something slightly different, and the third one is, well, slightly different again. And if everyone kind of like adds their own flavoring, things will deteriorate over time. So personally, I often do not allow this in my personal project that I have done, but it's more of a choice than a dogma. Another one is this one. Well, maybe the view should not depend on the model, because we would like to reuse view classes. And if we use these objects and classes in the model directly in the view, well, then we can't just take the view and put it somewhere else. So we want just primitive data types to be displayed in the view. So the view knows about integers and strings and stuff like that. And the controller now has the responsibility to take the customer object and then tell the view, okay, I would like a list. It should contain these fields. In these fields, you should put this information. So the controller becomes responsible for transforming data from the model into something that the view can use. And this is also an option you can have if you would like to reuse your views, for example. Thirdly, you can also put a restriction here that, okay, well, the view can access data in the model, but it can change data. It's read-only. So we don't want the view classes to be able to invoke functions in the model that can change the model in some way. We want it to be read-only. It exists as many MVCs as it exists programmers. Yeah, I can agree with that to some extent. It seems as if you need to think about the relationships, and as I said before, this is not the problem. The separation of the model and the user interface. That is clearly understood by most people. You hardly find really bad mistakes here. The things that people can decide on is, well, okay, how should the view and the controller communicate? What is allowed here? And should the view depend on the model, or should it be read-only, or should it be able to change things in the model? So if you decide to use the model view controller pattern, you should think about these things, think about what they mean in your project, and decide, so that you don't just say, well, we are going to use the model view controller pattern, end of architectural discussion. I think there's a link on the course homepage to a discussion about user interface architectures. I think Martin Fowler has had some posts about this, and you can read about it further. But I think it's time for an example. So let's take our little dice game, and well, just make a copy of it first. And model view controller dice game. So we will have the dice game, the vanilla one, the model view one, and now the model view controller one. So let's do a refactoring of this into model view controller and see what happens and how it can look, at least. Now it's not the most advanced application of all times, so hopefully we will manage in the time we have. So we already have the model and the view. Let's just run it and see that it compiles to start with, at least. Yes, Q to quit. Well, we can do a lot of fancy playing here. So let's add the controller package then. And what will happen here is that we will take a look at the view. In our model view separation, well, then we put view and interaction stuff in the same type here. We call it console player. That is probably not the best name anymore, and maybe we should name the controller player instead. So let's start a new type here. And what can the player do? Well, he can play the game. And what does the player need? Well, he needs the game, so he needs model dice game. And he will need a view also. So, but we will rename this one, I think. We'll rename it just console, I think. Good name. Zoom in a little bit, I hope you can see. So view console a view. And we can just take this this code here. Move it here. And now everything that has something to do with actually using the console should be put in the view class instead. So instead of having this code, the message and the right line, then we should just call the view a view display display instructions. And we add this function here instead. So, and then we should do something while we have some input. So let's just write something like this: a view get in input, and we will move this to the view. So what should happen then? Well, we should write the message again. View display instructions. And maybe we should just move this one also. It should become something like that. We should return it.
Thank you.
Oh, thank you. So, okay, we have instructions, and then we need to display the result also. A view display just send in the information that we like from the game. And that's about it. So, okay, something like that. We have a change there. So, in the view, you can see kind of like the logic of the user interface disappeared. The view now became like, okay, we have these functions in the view that we can use, but it really does not execute anything. It just does what it's told. Okay, I would like to display the instructions. Okay, I clear the console and I write this message. I would like to get some input. Okay, I read the key from the console. I would like to display the results. Okay, you need to send in who won, if the player was a winner, and the dice values. And in the controller, we have the logic of the user interface, so to speak, how this scenario plays out. Well, we should display the instructions first, and then we should get some input, and then we should display the instructions again, and the result. Do you think it will compile? No. Good guess. Accepting further. We haven't changed this part. We need to create the controllers, of course. And it is not the view that plays, but the controller that plays the game and uses the game, and the, let's call it view instead. So, we have the model view controller architecture instead of the model view separation. And as you can see, the view became a little bit more focused on actually being view. It handles the console in this case. You could imagine having a view that, well, does something else. Instead of getting input from the console, well, you should get input from voice. And if we implement this, we do it in a view, and we don't need to change the controller. There is one big mistake here in this this code. Can you spot it, you think? One little sneaky thing. If we look at the instructions, the message, it says you should press Q to quit. If I change this to something else, for example, if I do a Swedish translation, it would probably be S for sluta eller avsluta. Can I just change this here and it will work? No. Why not?
Förutsatt om just klickar på Q så avslutas det.
Exactly. So we have this instruction here, but this depends on this character here in the controller. That is probably not a good thing. So this is low-level input. And low-level input should be handled in the view, preferably. Instead, we should do something like wants to quit. Ask, use the view, well, does he want to quit? And in this case, we query the console. This is at least one step better, because, okay, this Q letter here now at least resides in the same type. We have encapsulated this into the same type instead of spreading this out on two different types. Even better would be to put this in a variable in the class, so that, well, chances are you change this and you forget to change here anyway. And you will probably be annoyed that why it doesn't work. Or vice versa. We have a question here. What if you set a bool in player to is playing and the view changes that bool? Yeah, that is of course one option. Then the view would become dependent on the controller. It uses something in the controller, and that is fine according to the pattern. So if you want that, that could be arranged. And maybe also if we have a more advanced user interface, a graphical user interface that kind of like lives on its own, that is a good option. To send like the event of someone wanting to quit to the controller, instead of the controller asking the user interface, maybe all the time also. Since you are experienced in web development, some of you, this is not really an issue because web applications are quite stateless. So you get into the controller and you execute and you do things once and then it's all over. And then you get the next call. In desktop applications, well, the application lives on and on and on and runs some kind of a event loop. And well, things then work a little bit differently. And you need to think about these things depending on your application. But typically, try to not spread things like this out. Typically in web applications you get, well, I have this ID in my HTML that is also used in my JavaScript, that is also used in my PHP code, and well, if I just happen to name something the same thing, because I was really not paying attention that this ID had already been used, I can get lots and lots of strange behavior from my application. And also if I decide to change this ID to something, chances are I forget to change in some places. So try to encapsulate information like this. Think about, okay, it should be at least be in the same package, at least be in the same type, at least be only once in the type. Yeah, so that things are easier to change for you. The same thing about if you use a database, table names have a tendency to be coded as strings here and there. So we need to add sorting, for example, and well, instead of writing functions, you write, okay, we take a string that is the column name in the database that we need to sort on, and we use this in our model or in our view, and suddenly we need to change this column name for some reason, and then we need to change it in not just the database, but everywhere. So you're like, have broken encapsulation, and changes becomes much harder. I don't think this is the example from the book. I know he uses the dice game in the first few chapters, but not throughout the rest of the book. But I will add this on GitHub. You are of course free to add your own implementations in different kinds of languages, and I think we will even make some other update to this dice game before we abandon it and consider dice games maybe a small problem. But yeah, as you can see, we have the same functionality, but we can select to structure our applications in different ways. And questions? No? A homework for you then for next lecture is to make a class diagram for this application. So we made a class diagram for the application, the model view variant. So make a class diagram for this one. And we will take a look at that in the next lecture. Yeah, it's not much of a problem description to put up. You should be able to play the dice game. And I think we did that in the first lecture. We wrote down the requirements, right? Yeah. So you can take a look at that. Any other questions? All right, we have one more lecture this week. And on that lecture, we will talk about the layers pattern. You can use layers to structure your code also. Yeah, it could be wants to play also. Wants to quit, wants to play. Yeah, maybe I did it wrong. I will check it out later. And we will take a look at components. Everyone talks about components, but what are they really? So we will take a look at that. Anything else? Okay, don't forget the peer reviews. Work with that. That is your primary focus. Make sure you email that to your groups before 12 o'clock tomorrow. So work. That's it for me. Bye-bye.